Can you believe this? China has actually officially announced a space mining plan. The universe is not only filled with resources beyond imagination, but more importantly, it isn't restricted by any sovereign borders. As long as you have the skill to get into space and the ability to bring the resources back, it's like owning a supermine that is inexhaustible and endless. About 4.3 billion years ago, a massive asteroid hit the moon, smashing right through the lunar crust and forming the South Pole Aitken Basin, with a diameter of 2,500 kilometers, a depth of 13 kilometers, and an area equivalent to half of China. What did Chang'e 4 discover in this pit? Olivine and pyroxene, and massive amounts of minerals that should only exist deep in the lunar mantle. Studies indicate that its concentration of platinum group metals is 80 times that of Earth's best mines, and the concentration of rare earth elements is over 200 times higher. Scientists estimate that 40% of the moon's total rare earth reserves are buried in this basin. Even crazier, China's Chang'e 5 has already brought back 1731 grams of soil from the moon, and helium-3 was detected in this soil. The energy produced by 1 ton of helium-3 is equivalent to 15 million tons of coal, and it is estimated there are 1 million tons of helium-3 on the moon, enough to last all of humanity for 10,000 years. Beyond the moon, asteroids in near-Earth orbit are treasure planets. Don't look down on these asteroids just because they lack volume or mass. They generally have two standout features. First, extremely high density, and second, extremely rich single resources. Because asteroids are small, their mineral types aren't as complex as Earth's. Instead, they concentrate on one or two types of minerals with staggering reserves. According to estimates, there are about 1,000 near-Earth asteroids that have been fairly well explored, and among them are treasures containing immense value. Experts speculate that the value of some asteroids could reach the trillion-dollar level. Take platinum for example. Scientists speculate that a single asteroid just 460 meters in diameter contains platinum reserves as high as 100 million tons. Gold is even more exaggerated. There is a small celestial body named Psyche that is simply a precious metal planet, covered entirely in gold, platinum, nickel, iron, and other precious metals. Experts estimate its total precious metal content may far exceed Earth's existing reserves, and if it could be mined, its value would be unbelievable. What kind of concept is this? Experts estimate Psyche's total value is around $100,000 trillion, that is 10 to the power of 19 dollars. What does that mean? Global GDP in 2023 was about $100 trillion. The value of this one stone is 100,000 times the wealth created by all of humanity in a year. You have to know that over 70% of Earth's surface is ocean and land, and the surface has plants, animals, soil, and other substances, so the enrichment of metals isn't high, and only specific mining areas can yield large amounts of metal. But this asteroid is different. It is a super invincible mega mine pit, full of treasures all over with absolutely no excess impurities. So, the core of near-Earth orbit mineral development is to focus on developing these asteroids, because they are closer to Earth and relatively speaking, it is easier to realize resource utilization. There is also a crueler truth. At the current rate of Earth's rare earth consumption, by 2045, key rare earth elements like neodymium, dysprosium, and terbium may face serious shortages or even the risk of depletion. What happens then? All electric vehicle production stops because motors need neodymium magnets. All wind power generation halts because generators also need rare earth permanent magnets. The production of phones, computers, and all electronic products will plummet. The entire human industrial civilization could regress by 20 years. But the problem is, currently launching 1 kilogram of material from the moon back to Earth costs 500,000 renminbi. That means even if you dig up pure gold, the shipping cost is more expensive than the gold itself. How exactly do we do space mining? Is it technically feasible? First, we must solve the problem of stable space communication. Space mining machines working in distant space must have stable and efficient communication guarantees to transmit data and receive commands in real time. This requires deploying a massive number of communication satellites in near-Earth orbit to build a global satellite signal network, achieving full signal coverage from near-Earth orbit to Earth. This explains why China previously submitted an application to the International Telecommunication Union (ITU) for the Guowang Low Orbit Satellite Internet Constellation, planning to deploy frequency and orbital resources for over 10,000 satellites. Simply put, it's about planning ahead, laying out an integrated space-ground satellite internet to provide communication support for future space mining, space exploration, and a series of aerospace activities. Next is the energy supply problem. Space mining machines need sufficient and stable energy to drive them for long periods of operation in space. So where does the energy come from? Either use small-scale nuclear power or rely on solar energy. But solar resources in near-Earth orbit aren't as rich as imagined, especially on the edges of asteroids where lighting conditions aren't friendly, making it hard to guarantee the stability of solar power supply. Therefore, to obtain a stable energy supply, nuclear power might be the more reliable choice. This requires developing and launching nuclear-powered spacecraft to provide power to space mining machines on a regular basis. Moreover, these space mining machines need to combine with drone technology and have autonomous endurance capabilities. When out of power, they can fly back to the nuclear-powered spacecraft to charge and after charging, automatically return to the work area to continue mining. Currently, exploration research on lunar resources has the highest global attention and the largest scientific investment. Helium-3 on the lunar surface can serve as nuclear fuel, and water ice resources on the back can be electrolyzed into rocket fuel. Spaceships flying from Earth to Mars can first go to a lunar base to refuel, with fuel demand being only 1/6 of that at takeoff. The lunar base will become a transit hub for space travel. This isn't sci-fi but China's formal aerospace plan. An even more amazing plan is that in long-term planning, there are ambitious proposals pointing out that China hopes to establish the first automated mining station in the asteroid belt by 2038, controlled by AI, cutting rocks with lasers, collecting metals with magnetism, and then using small rockets to send metal blocks back to Earth. Professor Liu Xinhua's team at the China University of Mining and Technology has developed a multifunctional space mining robot. Unlike the currently popular humanoid robots and robot dogs, the basic form of the space mining robot is a 6-legged mode, with 3 wheeled feet and 3 clawed feet. The main reason for this design is to adapt to the microgravity environment in space. Space mining robots need to complete geological exploration and mineral collection on extraterrestrial bodies, so drilling is an essential skill. In Earth's gravity environment, the robot's own weight is enough to support the drill bit boring in. But lunar gravity is only 1/6 of Earth's, and asteroids are mostly low microgravity, so how to get the drill bit to smoothly bore into the planetary surface became a big problem. To solve the drift caused by weightlessness, the research team thought of simulating the claw structure of insects, so they designed special claw feet for the space mining robot. Its claws use an array design. In a microgravity environment, its adhesion ability is stronger, and its grip is stronger, allowing the robot to fix itself in place in microgravity, facilitating sampling. At the same time, it can move according to the terrain. Not only can it adapt to the space microgravity environment, but by adopting a biomimetic 6-legged mobile structure, the robot's foot ends have 2 configurations, wheels and anchoring structures, which also allow it to walk on the uneven ground of asteroids. Currently, the prototype of the space mining robot has already applied for a patent with relevant departments and passed the initial review. This robot has successfully achieved walking, anchoring, and sampling functions in a simulated lunar soil environment, basically verifying the various performances of its preliminary demonstration. Space mining robots have to complete prospecting and mining work in space, facing not only the problem of microgravity but also a series of difficulties like extreme temperature differences, vacuum, space radiation, and weight and volume limits. So, how can the robot calmly deal with these difficulties? The research team built a training ground for interstellar miners to master the 18 martial arts of coping with the space environment. In Professor Liu Xinhua's team laboratory, this carefully built sandbox is the training ground for the space mining robot. This environment mainly considers 2 aspects. One is simulating the weathering environment of near-Earth asteroid surfaces dominated by sandy soil. The other is the microgravity environment, simulating microgravity effects by offsetting part of the gravity through vertical suspension. Team members introduced that after continuous training on the sandbox, the space mining robot can already adjust its own structural shape according to the working environment, adapting to the complex surface environments of extraterrestrial bodies. In addition, China's laboratories also precisely simulate the extreme environment of the lunar surface, a 1/6 gravity field, as well as an ultra-high vacuum environment. They simulated the high temperatures reaching 130 degrees Celsius during the day on the lunar surface, as well as the ultra-low temperature environment dropping to -180 degrees Celsius at night, and even down to -250 degrees Celsius in the polar regions. The ultimate significance of space mining isn't to sell resources on Earth for profit, but to push humanity out of Earth and truly become a multiplanetary species. If we can establish self-sufficient industrial bases on the Moon, establish colonies on Mars, and build mining networks in the asteroid belt, human civilization won't go extinct even if it encounters disasters in the future. This is the highest value of space exploration, not conquest but survival. Of course, China's interstellar navigation exploration is currently just getting started, and perhaps it will take another dozen years to gradually realize these goals like lunar development and large-scale space resource utilization. However, the distance of interstellar navigation is being shortened step by step in our continuous exploration. You and I might both have the chance to witness the miracle together in this lifetime. Regarding universe exploration, if you have any other thoughts, please discuss them in the comments section. Subscribing and liking is my motivation to keep updating.